Greetings and welcome to Lesson 2.6, Skewedness and the Mean, Median, and Mode. Here are your new terminologies for this lesson. Not very many of them, but still take your time to go through them. Skewedness of your data is a measure of how symmetrical or asymmetrical your data is around the mean. So it has to deal with the mean. We're going to have to do some calculations here on our data. Generally, we calculate the mean, the median, and visually we can just look to see what the mode is if we have one. So let's take a look at this data. And you can kind of tell just by looking at the data that it looks very symmetrical around the middle. Like if I folded this graph in half, it would be, and unfolded it, around that middle part, the image would look mirrored. That's symmetrical. In fact, it's perfectly symmetrical when your mean and your median equal one another. In this case, mean equals 7, median equals 7, and just by chance, our mode equals 7 as well, and therefore this data is symmetrical. Taking a look at a new set of data, we can see that if I folded this picture in half and unfolded it along that crease, it is not symmetrical. There's not the same amount of data on one side of the line as the other side of the line. So just folding it in half isn't going to tell us much. What we're going to have to do is we're going to calculate the mean and the median. And while we're at it, we might as well calculate the mode. Mode's always the easiest thing to spy because if it's graphic image like this, it's going to be the tallest column, so we know the mode is 7. Once we do our calculations, and I have the raw data, I do the calculations, my mean is 6.3 and my median is 6.5. What that means is the mean is to the left of the median and therefore it's left or negatively skewed. It's all about the mean. If the mean is on the left of the median in the mode, then it is left skewed. So you could probably anticipate what a right skewed value is going to be. It's going to be the mean is on the right of the mode and the median. Okay, so when it's left or negatively skewed, then the mean is on the left of the median and the mode. One more set of data. And again, we're going to try and figure out, is this data skewed? Now, the first thing you want to do is think about it mentally. If I fold this vertically in half and then unfold it along that crease line, is the same data mirrored on each side of the crease line? If it is, you can say that it's symmetrical. This is not symmetrical data. Therefore, we got to take it a little bit further. We need to analyze the mean, the median, and we'll throw in the mode too. Now the mode is the simplest, it's just the tallest column. So in this case, it's 7, just like it was in the two previous examples. But I want to calculate the mean and the median. And I have the data, I calculate it, and the mean turns out to be 7.7, and the median is 7.5. If we want to look at this as who's bigger than who, the mode is 7, which is smaller than the median, 7.5, which is smaller than the mean. So if you were to plot that on a number line, the mean is all the way to the right. That means that this is right or positively skewed. If the mean is to the right of everything else, it's positively skewed. And mostly if it's to the right of the median. The median is a nice indicator of where the middle of your data is. So if your mean is to the right of that, then it's right positive skewed. Let's look at 3 sets of data for Terry, Davey, and Mary. Now, just looking at the data, can we figure out its skewness? Sometimes it's pretty obvious, sometimes it's not. So let's take a look at Terry's. Visually, if I was to kind of draw a nice curve shape over those data points, you would see that there's a tail going out to the right. So I'm going to think that this is right skewed. There's some weight over on the right side, and therefore I think it's right skewed. I still have to run the numbers, but I'm going to say that's right skewed for now. Now let's take at Davey's letter count. Now, if I connect those dots, there's kind of like a hump of weight further down at 1. And I'm leaning towards left, but this one's harder to tell if it's skewed or not, because there's just like a slight little more weight to the left. I'll have to definitely run the numbers this time on Davey's letter count. Now, Mary's letter count. If I folded this in half on the 5, it's fairly symmetrical, not perfect, but it's relatively symmetrical. If anything, maybe it's leaning a little bit to the left, but we'll see about the data. We'll see about the numbers. So let's calculate the mean, the median. We'll take a look at the mode, and then we'll figure out for sure the skewness. For Terry's letter count, when we calculate the mean, it's 3.7. The median is 3 and the mode is 3. That means the mean is to the right of the median, and therefore my gut instinct that it had that little tail to the right of the data was correct. It is skewed positively in the right direction. For Davey's letter counts, when I calculate the mean, the median, and the mode, the mean is 2.7, the median is 3, the mode is 3, and my gut instinct was correct that there was extra weight to the left, and so it's negatively or left skewed. Now, here's where I have kind of an argument. When I calculated Mary's letter count for its mean, the median, and the mode, the mean was 4.6, the median was 4, and the mode was 4. It's slightly skewed to the right. But when you look at it visually, it's relatively symmetrical, so we could call it symmetrical. You've reached the end of this lesson.